Hi, my name is Natasha Gracia. This video is to demonstrate the parallel programming assignment on parallel matrix multiplication using OpenMP. Okay, so this is the sequential part. So these are the headers that allow me to use printing, memory allocation, also timing function. And then for this function here, it returns the current time in seconds using clock monotonic. I use it to measure execution time accurately. And then we have this one, void matmul. This function, it performs the triple nested loop, standard triple nested loop matrix multiplication. So the row loop selects a row from matrix A, and then the call loop selects a column from matrix B. The inner loop multiplies and accumulates the values. So this is typically the matrix multiplication algorithm. Then we have here our main. So let's go to here. This just reads the matrix size n from the command line, and then this is the memory allocation. I just allocate memory for the matrices, so the size can be chosen at runtime. And then here for random, this fills matrix A and B with random numbers. Then we got the timing sequential here. So this one is I record the time before and after the multiplication to measure performance. Then it's just the print result. It just prints the total execution time, and then here total execution time. And then for here, for free A, free B, free C, it's just to avoid memory leaks. Okay, next for my parallel side, for the functions, I mean the headers, I just added this one, include omp.h if you compare it here, because it has the parallel programming features. And then start here. So this function, it performs the same matrix multiplication, but each row is handled by a different thread. So this is the performance summary for my sequential. Let me check here my sequential. I got the results I got for n equals to 300 were 0.32 seconds, 0.032 seconds. Then for my parallel thread, this is 2, here's one, parallel thread 1, I got 0.029 seconds here. This is for thread 1. And then 2 threads, I got, let me see, this is my 2 threads, thread 2, I got 0.016 seconds. And then for parallel 4, where did it go? Okay, here, parallel 4, I got 0.015 seconds. And then for the last one, which is parallel 8, I got 0.029 seconds. So I observed good speed up for 2 and 4 threads, but performance dropped at 8 threads due to overhead and limited CPU cores. So in conclusion, I successfully implemented both sequential and parallel matrix multiplication.